Hello everybody. Thanks for joining our beloved online Rust Meetup. My name is Zsuzsana Dobosnés-Ler. I'm an IT recruiter of Mimox Kft. Mimox was established 20 years ago now. We are really open to developers' needs, so that is why we decided to organize Rust Meetups in 2018. We have organized Rust Fests as well, but we participated in Paris and in Rome too. Unfortunately, we have no Rusty jobs yet, but if you are interested in other jobs, you can find ours on mimox.com/jobs. Or if you have any questions or need some help about your IT career, we can help you too. Contact us throughout our website. Today, our presenter is Balázs Söptei. Balázs is a Scala developer at Qualisoft. He has been learning Rust since 2018. Besides programming, music is his passion. You can remember him from one of the presenter of 2019 Rust meetups. In this presentation, he would like to show two things. One is Async programming in Rust. The other one is the Actix framework, which makes it easy to develop async web applications. He will demonstrate the topic via data store app based on the framework, communicating through the protocol. During the meetup, you can ask from Balázs in our Matrix group. The link was sent yesterday via email. And after the presentation, you will have time to chit chat on Zoom. Link will be sent by us during the presentation. But now, Balázs Söptei on the stage.
Hi. Thank you for the introduction, Zsuzsi. And I am going to share my screen and begin the presentation. So, welcome everyone to the Season 3, Episode 2 of the Rust Hungary Meetup. I am going to talk about async await in Rust and the Actix web framework. Here I'm going to be scratching the surface, but I'm going to recommend some websites and documentation if you want to read further in any parts of the topics. So I have divided this talk into three major parts. Part 1 is async await, part 2 is Actix web, and part 3 I am going to demo my toy project, which is an async web server based on the Actix web framework. Okay, so I'm going to talk about async await in this first part. So let's start with what is asynchrony. So asynchrony is a concurrent programming model, which is an alternative to a series of other concurrent programming models, one of which is multi-threading. Most of you must know this. It is present in most of programming languages. Another one is called coroutines. They are present in Kotlin and the Go language, and in the latter they are even called Go routines with a G, so they have a funny name. And the third one I'm mentioning here are callbacks. They are most known in JavaScript, and there are more. I'm only mentioning these ones because these are the most famous. So yes, and before we begin, I would like to mention this async book, and here's the link to the async book. It is a very good summary of the topic in Rust. Going further, so I have brought you this diagram that compares a synchronous or sequential and an asynchronous program. So we have three separate tasks that take some time to complete. Let's see what this represents first. So in this model, these tasks are computed or executed one after another. And these color rectangles not only represent the time spent with the calculation, but they also represent time waiting. So the program or the thread is waiting for a task to complete. So it cannot do anything useful while the calculation is going on. So these are executed one after another. And in contrast to that, in the asynchronous model, the whole idea is to enable the thread or the program make useful work while it is waiting for a task to complete. So you can see it starts with the green task, task 1, and when it cannot progress, it switches to another task and so on. So, and well, the whole idea is that you do not wait in vain. So the program does not waste time. It can do something useful while one task needs to complete. So that's the whole idea of this model. Okay, next thing I would like to talk about is the async and the await keywords in Rust and the future trait. If I remember well, from Rust version 1.39, the async and the await keywords are stable, so you can use them in stable Rust. And the keyword async, it provides syntactic sugar. I'm going to show you an example what it does. Okay, so you can use the async keyword and you make the function or block or closure return a future. So here is the link to the standard library documentation for the future trait. The only thing I would like to mention here is that a future represents a task that may have not completed yet. It will complete sometime later if it's not completed yet. And as I mentioned before, the idea is to enable the thread or program do useful work while it waits for a task to complete, so it can switch between tasks that are asynchronous. Okay, async keyword, you can mark functions with async. I will show you that later. You can mark blocks with async. I have an example of that too. And currently you cannot mark closures as async in stable Rust, but they are available in Nightly. One thing I would like to mention here that in traits, the async functions are not yet supported in the standard library, but there is a trait called async trait, which enables that. However, the async book says that the async trait comes with heap allocations, so you might want to consider that when using it. So it has a performance cost. Okay, so the async keyword comes hand in hand with the await keyword, because in Rust, the futures are lazy, which means you have to drag them into completion. Until that, they do nothing. So you need to use the await to make a future, an asynchronous task do something. Okay. One rule is that you can use the await keyword only in async functions or blocks or closures. Oops. Okay, one other thing I would like to mention here is that in order to make futures work, you will need an executor, or in other words, you will need a runtime. And the Rust standard library doesn't have a built-in runtime. However, there are crates that provide runtimes for executing and computing futures and asynchronous tasks. And the async book mentions a bunch of them. And if you don't like those runtimes provided by crates, you can implement your own. So I have some silly examples. These are very simple pieces of code just to make a point, and I have it on GitHub. However, I copied and pasted it into the Rust playground. So, and I can show you some examples of asynchronous things. As I mentioned, there is no built-in runtime in Rust. For example, there is something in a futures crate. I am going to use this blockon function as a workaround. You will see why I'm using it. The first thing I would like to show you is this syntax. So you are using the async keyword here in this function definition. And you say it returns a U64, but actually what it returns is a future of a U64. The other way to write this is a little bit more verbose, but it is equivalent to this function notation. So if you don't want to use the async keyword, you can use a function, a regular function, and make it return something that implements a future, the output type of which is a U64. Okay, the body is not quite equivalent, but it's a simplification. It's a ready function. It represents a future that is ready on the spot. Actually, async functions have some compiler magic under the hood. So I'm going to show you that the two functions return the same output. I'm asserting the equality here in line 43. And you can see it ran without errors. And I'm using this blockon because the regular main function cannot be marked as asynchronous. I can show if you do so, it is going to throw a compiler error. And you can see it below. However, there are solutions provided by crates, and I am going to demonstrate it later during this talk. Okay, so the next thing I would like to show is that the futures are lazy, as I mentioned. So here's an asynchronous function that panics in the body, so it throws an error. But if you don't await this function, if you don't drive it into completion, then it won't panic. So because it's not a simple function, it returns a future. So the type of this is a future unit or future void. But if I uncomment this block, which calls another function that actually awaits this one, then it is going to panic. So let's see how it happens. Yes, you can see the thread panicked with the panic buyer's message, and I'm going to comment it back because I don't want it to panic anymore. Another thing I would like to show in this simple example is that futures and asynchronous programming comes with different types of control flow. And the futures crate, the link of which you have here, provides a handful of options. So for example, there's this trait called future extensions, and it provides a handful of adapters, one of which is map. So it takes a future, and with the map function, you can provide a closure that takes the result of the future and processes it further. And this increment and square is still a future. So if you don't await it or block it, it will be lazy still. So here I will show you that the result is as expected, but you need to block because this is still a future, and map is just one of the dozens of adapters that this future extension trait provides in the futures crate. The futures crate also has macros that help with the control flow. So here we have this macro called join, and the documentation says that it pulls multiple futures simultaneously. And here comes the power of asynchronous computation. So it's much, much more powerful than just simply awaiting them one after another, because it says that they are pulled simultaneously. And this macro can also be used only in async functions or async blocks. As I mentioned, there are async blocks, and I will show an example. This is one. So you just simply write async, and you can do some asynchronous logic within the curly braces. And the whole thing returns a future, and I can block it to run it into completion. Okay, another macro in the futures trait is the try join. It is similar to join, but it works with futures that return a result, and it is a fail-fast mechanism. So if one of the futures result in an error, then you get an error. So I have this try plus function, which returns a result. And it's actually a checked addition of two U8 integers. And I can make it return an error by adding two large numbers, because it is going to overflow, and thus this try join of these two will result in an error because one of them is an error. Okay, last macro I would like to show is the select macro. So it says it runs multiple futures simultaneously and allowing the user to respond as soon as any future completes. So it is going to have one result, whichever finishes first, and let the user interact with the program. I can imagine this is very useful in user interfaces. Okay, last thing I would like to show you in this simple example is testing. So a way of testing actually, because you can use block on in tests, but there are better ways, and I will show you that too. So there are crates that provide other solutions. So basically, by default, you cannot mark your test functions asynchronous. So I'm going to show if I try to run the tests, it is going to fail. But you can run it regularly and use block on if you want a solution, and you can see this this has passed. I'm going to show you later that if you have a crate that provides some annotations, you can mark your tests asynchronous. Okay, next thing I would like to show you is a benchmark of synchronous versus asynchronous mechanism or model in code. So I made this program that does a linear regression. So it takes a series of data points and it constructs a linear model from those data points. Here I have a sequential implementation. So this function is not asynchronous. It just calculates the necessary data for the regression one after another. And in the end, it returns a linear model. On the other hand, I have this asynchronous version of the regression. So it does the same thing regarding the input and the output. It takes a series of data points and it provides a linear model based on those data points. And instead of doing it all sequentially, there are some pieces of data that do not depend on each other. So they can be calculated independently and they can be calculated by using the join macro, so they can be polled simultaneously. And there's another point that where this can be done. These two are the kind that don't depend on each other, so they can be run asynchronously, independently, and they can be polled simultaneously using the join macro. And the output is the same. The difference is how we get to the result. Okay, so the thing I did using these two functions is that I ran a benchmark using the criterion crate. And I have the source in this benchmarks.rs. So I'm using criterion that supports asynchronous executing during benchmarks. And I have a data point series that is a size of 1 million. And I provided both functions with this input, and I measured the time using criterion. I'm going to enlarge this a bit. So this is the synchronous or sequential model. What you need to see is the mean estimate, and this is around 24 milliseconds for a million of data points. And compared to that, I have the asynchronous version that have 16 point something. And what I like to emphasize here is that not the absolute value is that counts here, but the difference between the two models. Okay, it was a simple measurement to demonstrate this, and if you would like to reproduce it, you can navigate to this GitHub repo and clone it and run your own measurements. Okay, next thing I would like to talk about is the Actix web framework, which is a framework that enables you to build web servers that are asynchronous. And as I mentioned before, if you have a crate that supports marking your main function asynchronous, you can do so. And based on the Actix runtime, you have this annotation, and you can mark the main function as asynchronous. And it is necessary because when you create and run the server, you need to await it in this web framework. So what do we see here? This main function constructs an HTTP server with an application inside and binds these to a host and port. And that's it. I'm going to show you what goes on in the background. But so it's as simple as that. You can configure your server like that. I'm going to show you the fine details. So basically the HTTP server instance allows you to accept HTTP requests and serve responses. And the application is responsible for routing the requests and connecting them to the business logic. Okay, so I mentioned this is a toy project which operates with an in-memory store, and this store can be replaced with an actual database connection, however, if you want to further develop this. But what this store actually looks like is that it's a trait, and it supports basic create, read, update, delete operations. As I mentioned, you can only use async functions in traits with some workarounds, with one of which is the async trait, and it has some performance costs. However, I didn't perform any benchmarks to compare if this would be replaced with a regular trait with non-asynchronous functions. So this is the data store trait, and the handlers, the endpoints are going to use this because they will delegate the mechanism to this data store. Okay, so the app data is a function that makes it possible to provide the application with shared data. So this data store is going to be shared while the application is running, and this configure function makes it possible. It makes it possible to configure the application. And what I'm configuring here are the endpoints, and the endpoints look like this. So basically, we have two kinds of URLs. One is the simple dash data, and the other one is dash data dash key, which in here key is a placeholder, it's a pattern, and you can extract the key, which represents a key in the data store itself. Okay, so what this configure endpoint does, it connects the URLs, which are here, with HTTP methods, and connects them to specific functions which are called handlers in the Actix web framework. So this is what it does, and you can see the names of the handlers here. I'm going to show the anatomy of handlers right away. So what this configure endpoints function does is basically it's calling the route function with different inputs, and it does the routing for the application. You can do it in place right here, so you don't have to outsource this to an external function. However, it is better for testability to do so. So I'm doing it here. Okay. So here are the handlers, which are async functions, and these are the ones that connect, that accept the results of the HTTP requests and return an HTTP response. And here you can see the handlers that correspond to create, read, update, delete methods, and what they do, as I mentioned, they delegate it to the store. Let's see what these function notations mean. Okay, so here, let's take this function. Here we have a path variable, which can be extracted from the URL of the request. So I have shown you here this. You can call this endpoint with any kind of key, and this key is extracted. And that is the functionality of this path of the framework. And it's type safe, so the type of key is usize, if I remember well. So it extracts the key and passes on to the handler function. Another thing is the store is in this function notation, and it is wrapped inside this web data, which is, as I mentioned, is responsible for shared data. So this is shared data, and these handler functions operate on the data by delegating the functionality to the data store. Okay, besides the path and the data, we have a JSON type that can be passed on by the framework. So it works with HTTP requests that have a JSON body, and it's extracted from the JSON and passed to the function in a type safe way. Okay, I believe I'm using only the JSON, the path, and the data. The framework provides more than that. So the Actix web framework has other kinds of extractors, such as a web form. You can pass on the results of web forms via that. It also has a one called a query. So you can pass on queries in the requests and the URLs. And I think that's it. Okay, let's take a look in the body of this one of these handlers. So this constructs this OK constructs an HTTP response builder, and you can further process it with this body function, and you can pass a body which is already serialized because this data store works like that. And since the store has asynchronous functions, you need to await it here to actually get the value and pass it on as a response body. So the framework provides a handful of HTTP responses. I think this project operates with OK responses most of the time because it's a toy project, but you have these methods that correspond to most of the commonly used HTTP response codes. Okay, so basically this is what this toy application does. The framework, however, provides a much more that you can use. So for example, you can serve static files, you can pre and post process the requests. I mean, you can pre-process the requests and post process the responses. And I will show you a link to the Actix official website, and you can read it and you can experiment with it for your own purposes. Okay, what I would like to show here, another thing in the tests, that, as I mentioned, basically by default you cannot mark your test functions async, but the Actix runtime provides a test annotation that makes it possible to do so. So here, first you can mark your asynchronous function with the keyword, and you can, since you can mark it with async, you can use the await keyword inside. This is a powerful feature of the framework. Another powerful feature is that you can use a test service and configure a test application there, and you can send test responses, test requests, sorry, to this test application and do assertions on the responses that it provides based on your requests. So you can test the whole application, test all the endpoints without having to run your application. Okay. I have this toy project on GitHub. Here's the link, so you can you can examine the code and you can fork it and clone it and play around with it if you want to in your free time. And here's the link to the Actix official website. It's a really well-documented framework. So here you have a handful of examples that can help you get started. If you want to get started with the Actix framework, I definitely recommend starting with the official website of the framework. Okay, now we have arrived to part 3, and I'm going to demonstrate this toy project of mine. So what you can see here, I will demonstrate it right away. So I have deployed this application to Heroku, and now I'm going to wake it up because it runs on 3 dynos that are asleep currently. And here you can see the application runs properly, which means we can now test it. So I'm going to use a command line version for demonstrating because I haven't made any front end to this application. So basically I will just send requests via command line. So the first is I'm sending a post request with a JSON body that includes some data. So it's a very simple, it's a very simple piece of data. It has a first name and a last name, and I'm sending it to the data endpoint. And now I have my response. So here, what I have done is that I have sent a post request with this endpoint URL to, and it routes it to the create, which creates the data in the data store. So now I have a single piece of data. I can query my data. So I will send a GET request for this data endpoint, and it's going to return an array which currently has a single piece of data, and here I have the key, and I can take this key and copy it and paste it here. So it makes it possible to query the data one by one. So if I send this response, it returns the single one based on the key. There are other things I can do because it's a create, read, update, and delete, so I can also update my data. So I'm adding another field, which is an age. So John Doe is 42 years old. And I have my response back. And if I query John Doe again, you can see that it has an age of 42 now because I have updated it before. Okay, another thing I would like to show you is deleting. Oh, have I pasted? No, I haven't. So I need to update the key. I can delete my data from the store. And if I query it again, you can see there is no entry with such a key. And if I query all the data again, you can see it returns an empty array. So this toy project works like this, basically. And as I mentioned, so it's not meant for production purposes, but it demonstrates well how easy it is to create a web server using the Actix web framework, and you can play around with it, and you can replace the in-memory store with an actual one if you want to use it for actual data store purposes. Okay, so I have arrived to the summary. So in this talk, I have shown you the surface of the async await keywords and the future trait in Rust, how to use it, what you can do with it, the power it has. And I have demonstrated the features of the Actix web framework using a toy project of mine, which is an in-memory data store running based on the Actix web framework. If you want to read more, I promise to display some links of websites and documentation. So as I mentioned, you have the Async book, which has more on the topic, much more and in detail. You can read the standard library starting with the future trait, and you can learn about the details of how it works and how it's designed. And you can use the Actix official website to get acquainted with the Actix framework and start your project using it. As I mentioned, I have my code examples on GitHub. So these are the examples I shown in the playground. These are just silly examples to make a point. These are not very useful. So this is much more useful because it shows how you can leverage the powers of asynchrony and how to benchmark using the criterion crate. And here I have the GitHub link for the repo for my toy project I have shown and demonstrated in this talk. So you can fork and clone it and play around with it if you want to. So this is all I wanted to say in this talk. Thank you for your attention. And if you have questions or comments, feel free to ask. Thank you. Zsuzsi, you're on mute.
Sorry. So thank you so much, Balázs, for the great talk. That was the second talk of the year. And the next one will be on the 29th of April. and you can schedule on meetup.com as well. So you can